Hello, today we're going to go over Chapter 3, Section 3 for Honors Chemistry, and we are going over mole-gram atom conversions. The mole is the SI, that's International System Unit, for the amount of a substance. A mole is the amount of a substance that contains as many particles as there are atoms in exactly 12 grams of carbon-12. So 1 mole is defined, 1 mole is defined as how many particles or atoms there are in 12 grams of carbon-12. And that has been studied many times. And so the number that we use for that amount is 6.022 times 10 to the 23rd power. There's that many particles. Okay, could be jelly beans, could be eggs, could be donuts. You just have 6.022 times 10 to the 23rd of something. That is what we call 1 mole. Very similar to if I have 1 dozen, that's just representing the number 12. So 1 mole represents this really large number of items, okay? And in this case, it's going to be atoms because we're talking about chemistry. We're talking about little atoms and molecules. All right, so there is Avogadro's number, another name for how many particles are in 1 mole, and that is it written out completely. So you'll see 6022, and then we have 20 zeros after that. So it's a very large number because atoms are very tiny. And so this is the value of particles in 1 mole. We also call this number Avogadro's number. And the abbreviation for Avogadro's number is a big N for number and a subscript A for Avogadro, for Amadeo Avogadro. All right, the molar mass, the definition of molar mass. Mass is measured in grams. And the molar part means I have 1 mole. So how many grams of each substance is in 1 mole? And this is equal to the average mass found on the periodic table. So when we look up an element's mass on the periodic table, that is that element's molar mass. That's how many grams are in 1 mole of that element. Okay, so it's found on the periodic table, and it is the sometimes called the formula mass, also the molar mass. They are numerically exactly the same. Formula mass is talking about 1 single atom or molecule. So the units for formula mass are AMU. The units for molar mass are grams per mole. What we are going to use is molar mass. So we're going to be using these grams per 1 mole. And the AMU that I mentioned earlier stands for atomic mass units. They're very tiny units. So if you're talking about a single atom, the mass of that single atom is going to be an AMU, or atomic mass units. All right, so let's get to conversions. If you are given in the problem the number of moles and you are asked to change it 2 grams, then you're going to multiply by the molar mass. This is just a little picture showing you visually what we're going to do, but what we use are, it's called dimensional analysis. So we're going to be canceling out units and writing out our number just like we did in Chapter 2. Okay, so the question that we're going to do down here is the example, and here is our given number. It's 3.5, so I'm going to write 3.5. And the given units are moles, so I'm going to put mole. And I'm also going to include the element. So He is the symbol for helium that we are dealing with in this problem. All right, and just like in Chapter 2, I'm going to put this over 1 just to remind us that this is on top of the fraction. Putting it over 1 does nothing to the value of that number. Okay, and so you can see the question says, what is the mass in grams? I want grams. So grams are going to go on the top of my conversions because that's our unknown. We're looking for grams, so I put them up top. And the one I want to cancel out is moles. So moles go down here on the bottom. Well, we just said that the grams over 1 mole is called the molar mass, and it's found on the periodic table. So we're going to use that knowledge. and 1 mole of He on the periodic table has a mass of 4.0026, and we're going to round it right here to the hundredths place. The 2 is less than 5, so it drops, so it's just 4.00. Okay, so there are 4.00 grams of helium in 1 mole of helium. So mathematically, all we're doing here is multiplying. Okay, 3.5 times 4, which gives me 14. Okay, and we need to watch our sig figs. We started with 2, so we're going to end with 2. The moles of helium have canceled out. So I have grams of helium, and that's what the question asked us for. It said, how many, or what is the mass in grams of helium? It's 14 grams. Okay, this is the opposite problem. So we're given grams in the question. It says 250 grams. So this type of problem will start with grams up here. And we are going down into what I'm going to call the valley of the moles. We're going down. So we're going to do the opposite of what we just did. Instead of multiplying by the molar mass, we are dividing by the molar mass. You don't have to memorize that at all. This is just like a little training wheel to help you visually if you get confused on these problems, because they are challenging. Okay, so we're going to start with our given 250 grams of cadmium, that's Cd over 1. Okay, and we're going to multiply it by a conversion factor. This time I start with grams, so I need grams on the bottom of my conversion factor. And the question asked us for moles, so moles are my unknown, and that means moles go on the top. Okay, in 1 mole of cadmium, it weighs how many grams? Cadmium is going to be all the way over here. So Cd has a molar mass of 112.41. 112.41. That's how many grams of cadmium are in 1 mole. That is the molar mass. Okay, grams per mole is the molar mass. And notice that before I wrote it as grams per mole, but it's a conversion factor. So I can also have 1 mole and how many grams there are. So 1 mole, this is grams per 1 mole, and this is 1 mole, it has this many grams. Just like we used 12 inches over 1 foot, or we could use 1 foot over 12 inches. So these are interchangeable depending on what we're starting with, right? Okay, so what is our answer? Well, that looks like 250 divided by 112. It's going to be very close to 2. Clear. 250 divided by 112.41. And we get 2.2. There's only 2 significant figures here because that 0 is not following a decimal. So we need to round our answer to 2 sig figs. So it would be 2.2. 2.2 moles of cadmium. All right. So that's how we go from grams, and the grams have canceled here. And we changed it to moles. The third type of problem starts with moles, and we're changing it to atoms using Avogadro's number as our conversion factor. So we're going to start by writing the given. So our given number is 5. Our units are moles, and this is carbon this time. So I have 5 moles of carbon over 1. I'm going to multiply that by a conversion factor where I want moles on the bottom. Okay, and we are asked to find atoms. So that means I need atoms on the top. How many atoms are in 1 mole? Well, 1 mole means 6.022 times 10 to the 23rd, anything. And so you can have 1 mole of atoms or molecules or sand, anything 1 mole is this number. So I have this many atoms of carbon in 1 mole of carbon. 1 mole of carbon is 6.022 times 10 to the 23rd atoms. Okay, and so we're going to take 5 and multiply it by this number. All right, now this is kind of tricky because there's a few ways you can do this, but there's a lot of ways that you can get this wrong in your calculator. So I'm going to show you guys a couple of ways. One way is to deal with this exponent later, so we can leave the times 10 to the 23rd and fix that later. The moles have canceled, so this is atoms of carbon. And I can multiply 5 times 6.022. If I do 5 times 6.022, I will get 30.11. This is just 2 sig figs, so I'm going to round that to 2 sig figs, so it's 30. Ooh, that's kind of sneaky. You'll see in a second. We'll still have 2 sig figs. But 30 times 10 to the 23rd is the same as 3 times 10 to the 1st. This is my 30 times 10 to the 23rd atoms. And when you multiply the 10s together, you can add their exponents. So that becomes 10 to the 24th. So I have 3, I moved the decimal over 1, 0.0 times 10 to the 24th atoms of carbon. Okay, the other way is to use your calculator, and I don't think that this does have the exponent button. So on your calculator, it might say EXP like mine does. Sometimes it's a capital EXP. Sometimes it'll say capital E, and sometimes it'll say times 10 to the N or times 10 to the X. So your calculator will have a button for exponents. Make sure you're using this button. E to the X, sometimes math teachers will tell you to use that for scientific notation. That is the inverse of the natural log. That is not what we want. So find the button on your calculator for exponents. Okay, and let's try this one out and see if we get the same answer. So we had 5.0, which is just 5, times 6.022, and then I'm going to hit the EXP button. Okay, it says lowercase e, and I know I just warned you guys, but that's okay. That's just how this calculator shows it. And now we put the exponent of 23. Okay, so here's my exponent. Yours might have a capital E here. That takes the place of the times 10. Okay, so this is taking place of times 10. Equals. Oh, and it didn't put it in scientific notation. If yours does that, sometimes there will be a button that says SCI. That changes it to scientific. Okay, but mine doesn't, so now I have to count. There's 3, 6, 9, 12, 15, 18, 19, 20, 21, 22, 23, and 24 places. So I would still get 3.0, technically 11, right, times 10 to the 24th atoms, but these go away when I round it to 2 sig figs. Okay, that's a lot of work. Let's do the next one. Opposite of that, if you're given how many atoms are in a sample and you want to know how many moles there are, you're going to write the number that's given. So we're going to write that 4.8 times 10 to the 25th. And I can tell right away by this exponent, it's going to be more than 1 mole, because 1 mole is to the 23rd. Okay, but I have that many atoms of scandium over 1. So I'm just writing the number that's given, writing the units and the element that are given. And you can see I want atoms to cancel, so atoms go down here. Atoms of SC go at the bottom. And it asks for moles, so moles are my unknown. Those go up top. 1 mole of anything is going to be Avogadro's number. So I have that many atoms of scandium and 1 mole of scandium. And then we are going to need our calculator. Okay, so on this calculator, I'm going to use parentheses here. So I have 4.8 exponent 25 end parentheses, because that's my top. value divided by the bottom value is going to be 6.022 exponent 23. And then let's close our parentheses and hit equals. There we go, 79.7. So we have 79.7077 moles of scandium. And if you guys are yelling at me through the screen that this is not the correct sig figs, you are right. So I need two significant figures in my answer. So I need to round it right here. Okay, so we're going to round between the 9 and the 7. The 7 makes the 9 round up, and I get 80 moles of scandium. Well, we have another problem here. This is one sig fig because it's not following a decimal. So how am I going to show that I need both of these to be significant figures when this is not significant? There's a couple ways. Some people like to put a line or a little bar over the 0. I don't prefer that way, though it's not wrong. I just don't like it. Your book actually uses a decimal place. So if you see the decimal place written, like I just wrote this one right here, that is telling you that the 0 to the left of that decimal is significant. So if you see 80 point, then that's 80 with two significant figures. Okay? All right. And the other way, the best way probably, is to put it in scientific notation. So if I were to change that to 8.0 times 10 to the first moles, I know for sure that that has two significant figures because now it is following a decimal. All right, back to our problems. For E, this is the whole enchilada. So we are going from grams to moles, and then we have to go moles to atoms. So this is a two-step process, and that's what this little diagram is trying to show us. We're going to divide by the molar mass, just like we did way up here. We're going to divide by the molar mass, and then we're going to multiply by Avogadro's number to change it to atoms. So first, let's go back to basics. Let's write out the given. So I have 36.0 grams of chlorine over 1. Okay, and we are going to divide by the molar mass. That just means that grams of chlorine are going to go on the bottom and moles of chlorine are going to go on the top. And I need to look chlorine up on the periodic table. Its molar mass is going to be 35.45. So I'm going to write 35.45 down here. And now grams have canceled. So now I know how many moles of chlorine once I do this, which is very close to 1, 36 divided by 35.45. Very close to 1 mole. So I should get really close to Avogadro's number because moles go on the bottom. In 1 mole of chlorine, I have 6.022 times 10 to the 23rd atoms. Okay, that's how many atoms are in 1 mole of chlorine. I'll put atoms of chlorine there. Okay, so now let's get our calculator and see exactly what we have. 36 divided by 35.45. Whoops. There we go, divided by 35.45. I'm going to hit equals just so the calculator doesn't do anything weird. So I have just slightly above 1 times 6.022 exp for exponent 23. And then I'm going to hit equals. And there we go, 6.115. So 6.11543, we can keep going, times 10 to the, that is a lot of places. Here's the decimal, so I go over 3, 6, 9, 12, 15, 18, 21, 22, 23. So I have that many, 6.115. How many significant figures are here? If you said 3, you're correct, so I'm going to round it right here. So that is 6.12 times 10 to the 23rd atoms of chlorine. That's my final answer. Let's put a box around it. Okay, to the 23rd power. atoms of chlorine. All right, so that is all of the types of conversions that you need to know. Let me show you the full valley of the moles right here. So this is just kind of like, a little training wheel to where if you see the question, find the given, so whatever number and unit they're giving you, and find out where you're starting on the valley of the moles. Are you starting with grams? Then you start here. Are you starting with atoms? Then you start here. If you start with moles, you're down here. And then the little arrows tell you what to do, okay? MM stands for molar mass. So on the left, I'm using the molar mass to convert between grams and moles. On the right, remember Na means Avogadro's number, and that's what we're using to convert back and forth over here. And also notice another way this is useful is when you go up out of the valley of the moles, you're going to be multiplying, the numbers get bigger. When you go down into the valley, the numbers are being divided, so they get smaller. Okay, so that is just the valley of the moles there to help you if you need it. And you can use this on the test. Right? Have a great day.